Factor completely. Given the polynomial p of x equals x to the fourth plus 8x squared plus 16, factor p into linear and irreducible quadratic factors with real coefficients. Factor p completely into linear factors with complex coefficients. For the first part, we can only use real coefficient. P of x equals x to the fourth plus 8x squared plus 16, and we recognize that this is a special trinomial. We can rewrite x to the fourth as x squared plus 8 is 2 times x squared times 4, and then 16 is 4 squared. This special trinomial gives us x squared plus 4, the quantity squared. This is the factor form with real coefficients only. If we were to use real coefficient only, then x squared plus 4 cannot be factored further. For part B, if we were to use complex coefficients, then we can factor x squared plus 4 alone further. In fact, if we were to set it equal to 0, then we have x squared equals -4. If we only use real numbers, then we will stop there and say there is no solution. But since we are using complex coefficient, we move on further and rewrite -4 at -1 times 4. But using complex numbers, -1 itself is already I squared, and then times 4. And so x squared equals I squared 4, or x squared equal 2I, the quantity squared. What this means is that when we get rid of the square, we have x equals plus or minus 2I. And so x squared plus 4 can be factored as x minus 2I times x plus 2I. Put all these together, we see that p of x equals x squared plus 4, the quantity squared, can be factored as x minus 2I times x plus 2I. This is x minus 2I, the quantity squared, times x plus 2I, the quantity squared.